Okay, this is the follow-up tutorial for the Fusion 360 joints and stuff tutorial over here. This tutorial we have so far, if you just watched the last video or you're catching up here, if we look at our joints and we animate our hinge joint and we animate the relationships, we can see our bridge is moving up and down and the pistons are also moving. This all works. There are 4 joint relationships here, and this works because for every state that the bridge joint hinges at, there is only one viable angle or one viable solution for all the other joints. They don't really have, the piston can't move any larger or smaller without that also affecting the angle that the bridge is at. Think if I didn't have this piston attached here at this joint and it was just flapping in the ground, it could be at any height and it wouldn't actually affect the bridge. You'd have to be connected to a previous part of the body. So we're going to do the next step now. Before we do that, I'm going to show you again how to edit it. So let's say you get this file and I have this cylinder here, and when I measured this cylinder, the diameter of this cylinder is 6 millimeters. Now let's say I actually want this to be larger. I want this one to have a diameter of 10 millimeters. So how I can change that is I can go over here, I can right click this and I can open that body. And this is why I picked both of these parts to be the same body, so I can edit in the same file. So what I want to do here is I want to go to my original sketches and I want to find the sketch that was this over here, and I'm going to edit this sketch, right click, edit sketch. And where I have 6 mils over here, I'm going to double click this and I'm going to change that to I'm going to change it to 12 millimeters. It's going to make it big. And if I press finish sketch here now, the glass cylinder is larger now. It's bigger, right? So now I've got to change my other things like my piston. So I've got to look for my sketch that had the piston part, which I believe was that one? Yeah, that one. This sketch over here, I'm going to edit this sketch. And where I have 2 mil over here, this was supposed to be 1 mil less than 3. So we can do 6 minus 1, 5, and I press OK. Oops, something happened there. What happened there? That worked. Okay. And then what was this revolve? Yeah, that sketch should be fine. Okay, and then we do the revolve. The revolve is that should also be okay. Yes. This one over here. This shape over here, I want to adjust this sketch over here. I want to move this. There we go. Okay, cool. That's our new upgraded plunger. And the last one we have to do is the inside of the tube. And where did I do that? Was it this one? This over here. So this one also, I'm going to make that 10. Cool. So now this is a larger cylinder now. This cylinder is a 12 millimeters diameter cylinder on the outside, right? 12 millimeters on the outside. The inside where the plunger area is, where we were doing our Bernoulli's equation, Pascal, where we're doing like that A1 over F1 equals F2 over A2. So A1 over F1 equals A2 over F2. The area we care about is this area of this inside circle, right? So we can actually go in here into Fusion and we can inspect and we can find this, we can select this area if we hold our mouse down We want that one. We can actually go here and we can find this area, 78.54. So we can write that down in the notes or whatever, 78.54. That's going to be our area. Now, if I go and save this, and if I go to my assembly, we see here we have this component is out of date. And so I'm just going to right click over here and I'm going to say get the latest. And as long as I've saved it and it's upload the latest version of this component. Now, obviously the size isn't right, so we can fix that design up later. But this is now a larger piston, and stop talking. Let's animate the joint and make sure it works. There we go, we have the large piston. My sketches are still showing here, but I can hide that later. So that's one thing we're doing with this tutorial. The next thing is I want to simulate the piston I'm going to push down with my fingers when I make this model. So I'm going to push down a syringe, and it's going to be connected by tubing to that large syringe. So the master cylinder is the one you're pressing with your hands, and the slave cylinder is this one over here on the bridge. As you push down the master cylinder, it's going to put the fluid out of the master cylinder and put it into the slave cylinder to lift up the bridge. So how we do that is we're going to make the master cylinder. So we'll just go here, we'll go to design, part design, create new. Now I'm just going to make a very simplified cylinder for this one. I'm just going to do 2 parts. This one I'm just going to make a circle over here. We'll make the inside diameter will be 3. 3R, R3. Outside diameter of 6. Yes, and we'll make the inside diameter of, this will equal, I'll do that, 6 minus 1. Cool. So I'm going to use both of these to simulate the syringe. We'll extrude the outside, and we'll make this 15 centimeters. So I'll make it 10 centimeters. That's actually too big. Let's make it 5 centimeters. 5 centimeters, okay. And I'm going to unhide the sketch so I can do the inside cylinder as well. So I'll unhide that sketch. I'm going to make it again. I'll make this 50, and this one will be a new body. So over here I have my 2 bodies. So I'll rename this the outside one the case, and I'll rename this the piston. And so that's just going to be a simplified version of my syringe. You can add your lovely features later. The point is you want to see that inside one move up and down. One thing I will do, I will actually make the inside piston look slightly better in one way so we can visualize it better. We'll go here, we'll go sketch, and I will actually do this feature. I'm just going to cut out the outside revolve. There. That's going to be the one thing I'm going to do is have that, and I'm also going to make the case out of clear acrylic. So when we do our movement, we can see what's happening. And now I'll save this. I'll save this under our slave piston. Save. Cool. So I have this thing saved. Now I'm going to add this in. We'll go to the tutorial. We'll go to the assembly. We'll go to insert components. We find the components, which is piston insert. So I have my piston over here, my body. I'm just going to bring it somewhere, which I'm going to move this to the side. Now visually, again, this can change drastically on what your design is. Some of you are going to hold it by hand, so it's not going to be physically connected. So you can have this anywhere, and we're going to try to make this work so you can have this cylinder in like any location you want, because it shouldn't matter. Because you're also going to be connecting it with like a plastic tube, and you're not going to model the plastic tube because it won't, I haven't found a way to effectively model the plastic tube because it's got to move in like a 3-dimensional space. But let's have this over here, and this is the piston. It's just floating here to the side. And I'm going to insert another copy of it. I'm going to insert it again. So I can have one of them be the piston, one of them be the case. Insert. And this one doesn't matter where it's being inserted. We'll just have it over here. So with the case, what we want to do is we want to ground the case. So we want to right click and we want to ground this to the parent. And so that means it's not going to move. This case cylinder is not going to move, and we'll even hide body. We will hide the piston. So the case is now ground, has this little anchor symbol over here. It's not going to move because its X, Y, and Z coordinates is not going to change. Now for the other piston, so the piston part of the slave piston, we want to go to the bodies. We want to hide the case. We have this part over here. We're also going to hide the sketches. We don't need the sketches. Cool. So for this one, we're going to do our relationships, and we're going to go to joints. And this one is going to be the type of joint this will be a cylindrical joint. And the one that moves is the first one we select. So we'll go over here and we want to select this tube over here. No, not that. We want to select this tube over here. And we want this to move down here. And press OK. And does that cylindrical joint move if we animate it? There you go. So that cylinder moves up and down. That's what we want this cylinder to be able to do. We want this cylinder to be able to move up and down. Okay. Now the issue we have here is when I try to animate my hinge, animate all the relationships, the piston's doing nothing here. Nothing's moving. So the new feature we're going to learn is this one. Under motion, we're going to use motion link. Motion link defines a relationship between two joints that are not connected, or is there between different degrees of freedoms. So we motion link, and what we're saying here is we're choosing one joint, so this cylinder over here. So the two joints we're selecting, this cylinder over here is one of our joints, and the other joint we care about is this one over here, the cylinder in the other piston. So we'll click this one over here. Cool. So now they're connected. Both of those joints are connected together in motion. So they should now slide if I press OK. They should move relative to each other. This is motion link. And now if is this going to work? Right click, animate joint relationships. All right, that's working. Now that's not working. So what's happening with this motion link? Edit feature. Oh, we have a slide and we have a rotate. Okay. Joint 5 is a. Oh wait, slide. There you go. Slides. Ah, ooh, wonderful. Oh, beautiful. It's working. Okay. Cool. So yep, we have to make sure they're both slides. So now, as I animate this hinge joint over here, let's animate it. Ah, it's somewhat working correctly, right? Yes, with these both pistons now moving, we can see how if they were connected by fluid, roughly the same actions happening here. Some things we've got to tweak. We know that when the bridge is down in its bottom position, right, that cylinder is no fluids in that cylinder, so all the fluid is going to be in the other cylinder. So there's going to be no, oh, sorry, I've used the word slave and master incorrectly. This is actually the master piston. So there's actually no fluid in the slave piston over here. The slave one's connected to the bridge. There's going to be all the fluid in the master cylinder. So what we'll do here is we go to this joint over here. So I'm actually going to edit this joint, and I'm going to change its starting position to be up here. Right, so it has no fluid in it. And I'll press OK. So now as I animate the bridge, they should be working in the right direction. Yes, as we push down the master cylinder, the slave cylinder fills up with fluid, right? Okay, now, what is the issue? This is great, right? As I push down this cylinder, and I believe I can actually even press this. If I press this over here, Oh, I can even drag this down. Look, as I drag it down, woo, that's pretty cool, right? It moves down with it. What's the issue with this? This fundamentally, it's moving correctly, but there's something wrong with the rate that it's moving.
The area, it's moving as if the area was the same.
Yeah, exactly. They're moving as if the area is the same, and I deliberately made the slave piston larger, so that wasn't the case. So we're going to have to find the area and then find the ratio of those two areas, and we can actually change the ratio that these two parts move. So if we go to inspect, we already measured this one over here was 74 point something, right? The area of this one is, if we hover over here, that area is 19.6. So we need to find the ratio between those two areas over there. So 19.6, 19.635 is that one. And if you don't have the Fusion to measure the areas, you can also do it by doing pi r squared. And the slave area is 78.54. So those are two areas. And is that just exactly 4 to 1? 78.54. Yeah, it's exactly 1/4. So because I doubled the diameter, I quadrupled the area because it's got a square in there somewhere. Okay, so now what I'm going to do here is, so under this motion study, under this motion link, I'm going to edit this feature. So I said here, for every time cylindrical 5, which is the master cylinder, every time it moves 10 millimeters, I want the slave cylinder to move 10 millimeters. That's not correct because our ratio here is 4 to 1 with our area. So we want, for every 4 millimeters that our master cylinder moves, I want the slave cylinder to move 1 millimeter. And I press OK. So now, if I drag this now, I have to move this much more. I have to move this much more to actually see if it moves correctly. And so where this is useful is I can find out for my motion, so I got this over here, and now if I animate this joint over here, animate joint relationship, I can see a few things. I can see if my master piston was only 50 millimeters long, I know there's not enough area, not enough volume in there to actually move the slave piston its full height. So you can, once you'll get your pistons next week because I've purchased them all, you can actually measure it in here to see how you can change it. Now, how you can change it in your design is you can do things like changing this hole over here where you're going to have your piston to rotate around. You can change that to be like closer to the center so it doesn't have to move as much. And that's how you can get away with the less volume you have available. Now, you are also lucky because they're syringes, and you know what syringes have on the side of them, right? They have a measurement on the side of them. They have the milliliters, and milliliter is a liter, liter is a volume. So you can actually tell by the milliliters, if you've got a 10 milliliter syringe, you know that can only put in 10 millimeters of fluid into the other syringe. So you can see how much it would move. So that's it for this tutorial. You could then, obviously you could pretty that up for your drawings, but that's just showing here this feature of having the syringe. You would want to do the same thing if you were doing a full bridge and you had the other half of the bridge on the other side as well. You could do both things. You could have both of your bridges being powered by this one syringe, because you just got to do another motion link connecting this joint to the syringe on the other side if you had a second half of the bridge on the other side of your drawing. If you're doing something like a mechanical claw and you might have multiple pistons in there, you might have multiple of these master pistons to do different actions. So if you look at a real life machinery, a real like an excavator or a digger, you would have One of them could be the piston to lift up one arm, and the other one could do to lift up another joint in there to have multiple things happening in your excavator. Any questions about this before I finish the tutorial? No? One thing that I haven't really benefited a lot from, but it's my next step that I'm going to learn with, is using the motion study. So motion study does stuff like you animate the joints and it can find out how much the joints actually move. So if we go over here and do a motion study, I think I can add this joint to the motion study. I can add this joint and I can add my cylinder. All right, so what the motion study does is I can calculate select the curve to animate the joint. So I want to animate the thing over here, and I want to say I want it to go to, what was it, 60 degrees? Yep. Oh, sorry, not that one, not that one. This one, the bridge joint. I want this one to, over here, I want it to go to 60 degrees or 60 degrees, I think. I want to go to 60 degrees and, or is it minus? I think it's minus 60. That's probably positive. And I want it to start at, okay. So I do this here, and now if I do this study, and I bring this over here, what this thing does, I believe, is you can pick particular points to move at. You can move multiple joints at the same time at a different particular rate. So not as useful for our bridge where you only have one output, but very useful if you're doing like a mechanical claw or an excavator, where you say within the first second, I want one of my joints to move to this angle, and I want another joint to move to another angle. And that's how you get multiple joints to articulate and represent a particular motion, because otherwise it's kind of difficult for you to manually, you got to manually add in a value. So I want to manually move this joint this way, manually move this joint another way. But you can do a motion study where you can say, I want joint number 1 to move 12 degrees, and I want joint number 2 to move at 6 degrees, and then you can get your thing actually moving. If I do a second tutorial later in my own time, I might do one showing how it would work like with a mechanical claw with multiple actions. So your tutorial today is you're going to finish your bridge tutorial, and I want you to connect up a motion linking for the master cylinder.